Silence. Beyond the atmosphere of our planet, there is absolutely nothing. Aim a telescope at the nearest star, and you won't detect the hum of a warp drive. You won't intercept a stray radio broadcast of alien news. You won't spot the lights of a galactic highway. There are no cars, no alarm clocks, no voices, just static. Your brain reads this lack of noise as safety, or it feels peaceful. You assume that if there is no sound, then there is no one out there to threaten us. It feels like an empty room, and empty rooms are safe. But that feeling is a psychological bias, not a physical fact. Ask yourself, is stillness in fact safe? On Earth, when a jungle goes entirely quiet, you don't relax, you freeze. You know that the birds and insects have stopped singing for a reason. They are hiding. The stillness isn't peace. It is a biological alarm system. It signals that the rules of the environment have shifted from live to survive. So why do we examine the universe and assume the silence means we are alone? The galaxy is billions of years old. It has billions of habitable planets. By all the rules of probability and thermodynamics, the sky should be buzzing with trade, with expansion, with empires. It should be deafening. The fact that it is stone silent signals that something is muffling the sound. Or worse, something is eliminating the source of the sound entirely. We are the anomaly. We are the sole ones making noise in a room where everyone else is either dead, hiding, or locked away. Tonight, we are going to confront the machinery behind that silence. We are not just looking for hunters. We are going to examine the mathematical walls closing in on us at the speed of light. We will study the thermodynamic laws that force gods to sleep. We will analyze the cosmic prison that expands faster than we can escape. And finally, we will question the code of reality itself. The sky is quiet for a reason. And it's not because it's barren. It's because the trap is working. Let's examine the numbers. Let us begin with the most aggressive solution to the paradox. It was proposed recently in 2021 by the economist and futurist Robin Hanson, and it, at its core, changes the way we have to think about extraterrestrial life. Usually when we consider aliens, we project our own human values onto them. We imagine they are curious explorers, wise diplomats, or maybe scientists coming to study us. We assume that a civilization can choose to be anything it wants to be. But Hanson's model strips away this sociological optimism and examines civilizations through the cold, hard lens of statistical selection. The model relies on a simple, brutal evolutionary logic. It contends that over a timeline of billions of years, the behavior of civilizations is not determined by their culture or their morality. It is determined by their survival strategy. Hanson divides all potential civilizations into two strict categories. Category 1 is the quiet. These are civilizations that remain on their home planet. Maybe they achieve a perfect sustainable utopia. Maybe they are philosophers who lose interest in the physical world. Or maybe they upload their minds into a virtual paradise and lose interest about the stars. But this is the problem with being quiet. If you remain on one planet, you are vulnerable. Ultimately, an asteroid hits, or your star flares, or a supervolcano erupts. Quiet civilizations, by their nature, have a steep extinction rate. In the vast statistical sample of the universe, they are ghosts. They appear, they do not expand, and they fade without a mark. Category 2 is the Grabby. These civilizations are different. They are defined by one defining trait: expansion. They reshape their environment. They send out probes to neighboring stars, they colonize, and once they start, they never stop. Why? Because expansion is a survival mechanism. If you occupy 2 star systems, you are twice as hard to kill as a civilization that occupies 1. If you occupy 1,000, you are in effect immortal. This yields a selection pressure. Over time, the universe inescapably fills up with Grabby civilizations, purely because they are the ones that do not die. They are like a fire in a dry forest. The fire does not hate the trees. It does not negotiate with the bark. It just converts the available resources, matter and energy into more of itself. So, ask yourself a question. If the universe is 13.8 billion years old, and if Grabby civilizations are the sole ones that survive in the long term, why is the galaxy not full of them? Why are we not seeing Dyson spheres around every star? Why are we not being mined for resources right now? The standard answer is maybe they do not exist. But Hanson's math hints at a much darker conclusion. It signals that they do exist, and they are vast. The reason we do not see them is not because we are alone. It is because of where and when we are standing. To understand why the sky looks barren, we have to dismantle your intuition about observation. You trust your eyes. You assume that if you gaze up and see nothing, then there is nothing. Yet in statistics, this is a fatal error known as selection bias. Let us run a thought experiment to illustrate this. Imagine a large flat piece of bread representing the universe. Now, imagine that mold starts growing on it at random spots. These spots are the Grabby civilizations. They are aggressive. They expand swiftly, turning the bread into green fuzz, consuming the nutrients, and rewriting the structure of the bread to suit their needs. Now, imagine you are a simple, microscopic bacterium living on that bread. Here is the critical constraint. You cannot evolve inside the mold. The mold devours everything. If life tries to start inside a Grabby civilization's territory, it is either sterilized or assimilated at once. Therefore, the sole location a naive, independent observer like you can emerge is in the clean, open gaps between the mold patches. This yields a paradox of perception. You survey your environment. You see clean, fresh crust. You see vacant space expanding to the horizon. You say to yourself, the bread is safe. There is no mold here. I must be the first life form in existence. But are you the first? No. You are just suffering from survivor bias. You are observing the universe from a survivor pocket, a temporary gap between the expanding empires. The stillness of the night sky is not proof that the universe is barren. The stillness is the precondition for your existence. If the sky were not mute, you would not be here to witness it. Hanson uses this logic to flip the Fermi Paradox on its head. The fact that we are here, seeing nothing, is precisely what the model predicts. We are stationed in a quiet zone. But this is the twist. The mold is not static. It is growing. The open gaps are shrinking. The fact that we see an untouched universe is not a blessing. It is evidence that we are living in the final moments before the gap closes. We are the anomaly that exists only because the fire has not reached our tree yet. But surely, you might contend, if these empires are so large, we would see them approaching. We would see their ships, their megastructures, or the heat from their industries. We have powerful telescopes. How can a civilization hide if it is consuming galaxies? This leads us to the physics of the expansion. The model does not just predict that they exist, it predicts how fast they move. And this velocity is the variable that turns this theory from a hypothesis into a nightmare. Hanson's calculations, based on the age of the universe and the size of the gaps required to allow human evolution, suggest that Grabby civilizations expand at a significant fraction of the speed of light. We are talking about speeds greater than 50% of the speed of light, and conceivably closer to 80% of the speed of light. Why does this speed matter? Because of the ultimate limit of information transfer. In our universe, nothing travels faster than light. Light is information. If an event happens a million light years away, we only learn about it a million years later. Now, consider the geometry of the trap. If a Grabby empire is expanding towards us at 80% of the speed of light, the light from their front line is only moving 20% faster than the front line itself. Picture it like a supersonic jet flying towards you. You do not hear the engine because the plane is moving faster than the sound waves. The sound hits you at the precise same moment the plane slams into you. The same logic applies here. The image of the alien expansion, The light from the stars they're consuming is barely outrunning the expansion itself. You would not see a fleet darkening the stars for thousands of years. You would not see a slow, creeping darkness. You would gaze up at a familiar constellation like Orion or Taurus. You would see it suddenly fade or change color. And before your brain could process the anomaly, before our astronomers could draft a paper about it, the physical expansion front would hit the solar system. What is this front? It is not an invasion fleet. It is a wave of molecular reorganization. A civilization this evolved has no interest in our territory. They want our matter. They need the hydrogen in our sun and the carbon in our bodies to fuel their computers. To them, we aren't enemies to be fought. We are just unorganized atoms waiting to be optimized. The invisible wall is hurtling towards us, and the stillness of the sky is merely the shadow cast by the tsunami before it crashes down. There is one final piece of evidence embedded in this model, and it relates to time. If we are living in a gap, how long does the gap last? Are we safe for another billion years? Or is the end happening next Tuesday? To answer this, we have to observe power laws. In statistics, a power law describes a distribution where a few items are enormous and most items are small. Consider cities on Earth. There are a few massive metropolises like Tokyo and millions of minuscule villages. The Grabby aliens model points to the universe follows this pattern. There are a few colossal, ancient empires that control 99% of the cosmos, and we are living in the space between them. Yet the most chilling part of Hanson's work is the calculation of our arrival time. Humanity has arrived on the cosmic scene approximately 13.8 billion years after the Big Bang. Is that early or late? For a great while, we thought we were average, but Hanson contends that we are exceptionally early. The era of star formation will last for trillions of years. Most life should arise trillions of years in the future. The fact that we are here now, at the very dawn of the universe's habitable era, is statistically suspicious. Why are we so early? The model gives a chilling answer. Because later on, there will be no vacant space left. If we had attempted to evolve 10 billion years from now, we would not have been able to. The gaps would be closed. The mold would have covered the whole bread. The only time a free, independent civilization like ours can exist is right now, in this brief window of time before the Grabby civilizations meet and fill the volume. This signals that our earliness is a timer. We are living in the golden hour of the cosmos. Hanson estimates that the remaining time before a sphere intersects with Earth is somewhere between 200 million and 2 billion years. That sounds like a great while to a human. But to a geologist or an astronomer, it is an instant. It means the universe is not a vast open frontier holding out for us to explore. It is a closing door. We are not the masters of the galaxy. We are the last generation of free matter before the reorganization begins. So, this is the first level of the spiral. The silence is not peace, it is the quiet before the collision. But what if Hanson is wrong? What if there are no expanding empires? What if the universe is full of sophisticated civilizations, but they are all hiding? This leads us to the second theory, and a very different kind of horror. Let us suppose for a moment that the Grabby aliens model is wrong. Let us suppose that there are no expanding empires rushing towards us at light speed. The universe is safe from invasion. This should be comforting. Yet if the universe is full of sophisticated civilizations, and they are not expanding, where are they? Why are they not building Dyson spheres? Why are they not broadcasting their art and science to the cosmos? This leads us to the second theory on our descent. It is called the Aestivation Hypothesis. It was formalized by researchers Anders Sandberg, Stuart Armstrong, and Milan Cirkovic. The term estivation is a biological concept. It is similar to hibernation, but instead of sleeping through the cold winter, an animal sleeps through the hot, dry summer to avoid dehydration and heat stress. The hypothesis indicates that sophisticated civilizations are not dead. They are not hiding, they are sleeping. But they are not sleeping because they are tired. They are sleeping because they are holding out for a better time to exist. To understand this, we have to observe what unsophisticated civilization in fact does. They have no need to claim territory. They have mastered matter. They have no need to fight for food. They have mastered energy. The only thing left for a godlike civilization to do is to think, to process information, to run simulations, to create virtual worlds. So the paramount resource for a Type 3 civilization is not gold or water. It is computation. And computation has a physical cost. Imagine a teenager stationed in a dark basement, playing an intricate video game. He does not care about the weather outside. He does not care about the economy. He only cares about the frame rate of his computer. If the room gets too hot, his computer overheats and slows down. He has to pause the game. The Aestivation Hypothesis contends that the universe right now is that hot room. It is too hot for efficient computation. So the civilizations have uploaded their minds into machines, lowered the clock speed, and entered a deep sleep, holding out for the cosmic weather to cool down. We are not alone. We are just the sole ones foolish enough to be awake during the heat of the galactic afternoon. Why does heat matter so much? Why would a civilization wait billions of years just to cool down a couple of degrees? To understand the motivation, we have to dig into the laws of thermodynamics. Specifically, a rule known as Landauer's principle. Rolf Landauer, a physicist at IBM, discovered a foundational link between information and energy in 1961. He proved that information is physical. You cannot process data without affecting the physical world. Specifically, he showed that the act of erasing a bit of information releases a minuscule amount of heat. The formula for this minimum energy cost is kT natural log of 2. Within this equation, K is the Boltzmann constant, and T is the temperature of the environment. Examine the variable T. The energy cost is directly proportional to the temperature. This tells us that thinking is expensive in a hot environment and cheap in a cold environment. Right now, the background temperature of the universe, the cosmic microwave background, is approximately 2.7 Kelvin. To us, that seems cold, but to a supercomputer executing simulations of entire realities, that is boiling hot. If you try to perform massive calculations today, you have to spend an enormous amount of energy just to cool your computers down to absolute zero. You are fighting the universe. It is like attempting to build an ice sculpture inside a sauna. You spend 99% of your energy fighting the heat, and only 1% on the sculpture. Yet the universe is expanding and cooling. In several trillion years, the background temperature will drop to mere fractions of a degree above absolute zero. If you wait until then, the variable T in the equation drops to almost nothing. This is not a small difference. It is an exponential advantage. If a civilization waits for the cold era, they can perform 10 to the power of 30 times more calculations for the same amount of energy. Consider that number, 10 with 30 zeros. It is the difference between thinking a single thought and simulating the whole history of the human race. So, logic dictates a strange strategy. Do not expand, do not explore, build an immense computer fleet, park it near a black hole, set the alarm clock for 10 trillion years in the future, and enter dormancy. This theory converts the Fermi Paradox from a mystery of biology into a problem of economics. We typically think about aliens as explorers, like Captain Kirk or Columbus. We assume they want to see what is over the next hill. But exploration is an emotional drive, not a logical one. A logical superintelligence cares about maximization. If you have a limited amount of energy in the universe, and you want to maximize the amount of happiness, knowledge, or life you can experience, then living right now is the worst possible investment strategy. Imagine you have $1,000. You can spend it today and buy a sandwich, or you can put it in a bank account with an infinite interest rate and wait. If you wait, that $1,000 becomes enough to buy a planet. Any logical civilization that understands the math will choose to wait. They are essentially shorting the universe. They are holding their assets, holding out for the market value of entropy to crash. This accounts for the silence. The reason we do not see huge empires is that huge empires are efficient. They do not waste energy radiating light and radio waves into space. That would be like burning money. They are probably compressed into small, cold, dark objects, possibly disguised as planets or asteroids, sitting silently in the void. They are dormant. Their processors are executing at minimal speed, maybe 1 clock cycle per century, just monitoring the environment. They are the supreme hoarders. They have hoarded the energy of their stars and sealed the doors. And this brings us to the horror of our position. We are not the chosen ones. We are not the first ones. We are the economic illiterates of the galaxy. We are running around burning coal, splitting atoms, and radiating heat into the void, entirely unaware that we are squandering the most precious resource of the future. We are like a child who finds a suitcase full of winning lottery tickets and uses them as kindling to start a campfire because he is cold. Yet there is a darker implication to this theory. If the galaxy is full of sleeping giants who are hoarding resources for the future, how do they view us? We are loud, we are hot, and we are destructive. Every star that burns today is a battery that will be empty tomorrow. The sun pours vast amounts of energy into space, and that energy disperses and becomes elevated entropy waste heat. It is lost forever. From the perspective of an eye-estivating civilization, humanity is not a fascinating new species. We are a leak. We are a chaotic, inefficient process that is destroying the potential value of the galaxy. We are vandals. Imagine you own a library of rare books. You lock the doors and go to sleep, planning to read them all in the morning. In the middle of the night, you hear a noise. You wake to find a colony of rats chewing the pages of your books and nesting in the covers. Do you try to communicate with the rats? Do you establish a diplomatic channel to ask them why they are eating the paper? No. You call the exterminator. The Aestivation Hypothesis indicates that there might be a limit to how much noise we are allowed to make. Right now, we are confined to one planet. We are burning only the energy of the Earth and a minuscule fraction of the Sun. We are a minor annoyance, a minor leak in the roof. Yet we are planning to expand. We want to become a Type 2 civilization. We want to wrap the Sun in a Dyson swarm. We want to colonize the galaxy. If we do that, we become a major threat. We start consuming the resources that the sleepers are saving. We start raising the temperature of the galaxy, delaying the cooling era. At some point, the cost of letting us live exceeds the cost of removing us. The stillness of the universe might be the result of a tolerance threshold. Maybe other civilizations began to expand, began to make too much noise, and the sleepers woke up just long enough to shut them down. How would they do it? This is where the horror becomes physical. If a civilization is developed enough to manipulate the thermodynamics of the universe, they have no need to send a fleet of ships to destroy Earth. Ships are slow and expensive. They would use automated systems, passive defense mechanisms left behind to guard the galaxy while they sleep. Consider a museum alarm system. It uses laser beams. If a thief crosses the beam, the alarm activates. In the cosmos, these alarms could be monitoring heat signatures or radio waves. If a star system suddenly becomes too loud or too hot, the system activates a sterilization protocol. The most efficient weapon would be a directed energy burst, a gamma ray burst, a narrow focused beam of high energy radiation moving at the speed of light. The source could be thousands of light years away. We would never see it firing. The beam would hit the Earth with the power of a supernova. It would strip away the ozone layer in an instant. It would ionize the atmosphere. It would turn the nitrogen and oxygen in the air into nitrous oxides, blocking the sun and creating a toxic, radioactive smog. Complex life would die within months. The machinery of civilization would grind to a halt. The noise would stop. And once the silence returns, the system would return to sleep. We examine the history of Earth and we see mass extinctions. The Ordovician, the Devonian. We assume they were caused by natural disasters, asteroids, volcanoes. But what if one of them was a warning shot? What if we have already tripped the alarm once, but we were too rudimentary to understand what hit us? The Aestivation Hypothesis tells us that we are walking through a sleeping giant's bedroom, banging drums and lighting fireworks. We think we are celebrating our existence, yet we are just tempting the hand that holds the fly swatter. But let us suppose the sleepers are not there. Let us suppose the universe is not holding out for the cold. Let us suppose that everyone is awake, active, and playing the game of survival right now. That brings us to the third theory, the one that converts the stillness into a weapon. The Aestivation Hypothesis is chilling because it dehumanizes us. It suggests we are ignored like insects. Yet there is a third theory that is significantly worse, because it restores our status. It indicates that we aren't bugs, we are rivals. And in a universe governed by the laws of thermodynamics and evolution, a rival is a target. This is the dark forest theory. It was popularized by the science fiction author Cixin, but do not let the fiction label fool you. The core of this theory is rooted in hard mathematics, in particular in game theory and the prisoner's dilemma. It challenges the optimistic assumption that sophisticated civilizations evolve into peaceful, moral beings. We like to believe that technology brings wisdom. We observe Star Trek and imagine a galactic federation. Yet the dark forest theory contends that morality is an evolutionary luxury. It only exists within a community where resources are abundant and communication is instant. In the cosmos, neither of these conditions is met. To understand why the universe might be a slaughterhouse, we have to observe two core axioms of cosmic sociology. Axiom number 1. Survival is the primary need of any civilization. A species will do absolutely anything, including genocide, to prevent its own extinction. Axiom number 2. Civilizations continuously grow and expand, but the total amount of matter in the universe remains constant. This yields a fatal mathematical conflict. You have an infinite desire for growth trapped inside a finite container. This is a zero-sum game. Every star system occupied by another civilization is a star system you can never use. Every energy source they harness is energy denied to your descendants. On Earth, when nations compete for oil or land, they can negotiate. They can sign treaties. They can trade. Yet the sole reason diplomacy works on Earth is that we share a biological context. And more importantly, we can talk to each other in an instant. In space, these safety nets are non-existent. Imagine a vast, pitch-black forest at night. It is dead mute, but it is not barren. The forest is full of armed hunters stalking through the trees like ghosts. They gently push aside branches that block their path, trying not to make a sound. They even control their breathing. Why are they so quiet? Because the forest is crowded. Everywhere there are other hunters. And in this forest, there is one iron rule. If you find another life, another hunter, an angel, a demon, a helpless infant, or a tottering old man, there is only one logical thing you can do. Eliminate it. Why eliminate it? Why not say hello? Because in the dark forest, hell is other people. The stillness of the universe is not a natural state of peace. It is a forced camouflage. Every civilization that was loud, every species that broadcast its location to the stars in a naive attempt to make friends, has already been eliminated. The ones left are the mute ones, the distrustful ones, the ones who listen but never speak. You might contend that this view is too cynical. You might say, surely a civilization developed enough to travel faster than light has evolved past the need for violence. Surely they would be curious about us. Why not just establish a dialogue? The reason you cannot talk is a concept in game theory called the chain of suspicion. In the cosmos, you are separated by enormous differences in biology, culture, and language. You have no way to grasp the alien mind. You cannot look them in the eye. Let us run the logic chain that a civilization must go through when they detect a signal. Suppose you are an alien commander and you detect Earth. You have to make a decision. Step 1. You cannot judge our intent. We might send a message saying, "We come in peace," but that could be a lie to lower your defenses before an attack. You have no way to verify the truth. Step 2. Even if you assume we are benevolent right now, you have no way of knowing if we will remain benevolent in the future. Political regimes change, resources be depleted. A peaceful republic today could become a desperate, fascist military dictatorship in 1,000 years. Step 3. The recursive trap. Even if you know we are good, and we know you are good, you have no way of knowing if we think you are good. This is the chain of suspicion. It is an infinite feedback loop of doubt. I think that they think that I think they are perilous. Without the ability to communicate in an instant and verify trust, the mathematical value of trust drops to 0. Within this environment, benevolence is a weakness. It is a survival liability. If you assume the other civilization is nice and you are mistaken, your entire species goes extinct. The cost of the mistake is infinite. If you assume the other civilization is antagonistic and you attack first, you survive. The cost of the mistake is 0. Evolution selects for the survivors. Therefore, over a timeline of billions of years, the universe is inescapably populated by civilizations that shoot first and ask questions never. The stillness is a standoff. It is a Mexican standoff in a dark room involving millions of participants, all pointing guns at each other, terrified that if they cough, everyone will fire. This paranoia is amplified by the laws of nature, specifically by the speed of light. We frequently overlook that light speed is not just a speed limit for travel, it is a speed limit for information. Distance is the ultimate enemy of trust. On Earth, diplomacy works because communication is, in effect, instant. If a country moves troops to a border, the other country can call the hotline, demand an explanation, and de-escalate the crisis in minutes. In space, the phone line is dead. If you detect a civilization 100 light years away, you're not seeing them as they are now. You are seeing them as they were 100 years ago. You are looking at a ghost. If you send a message, "Hello, we are friendly," it takes 100 years to get there. Even if they reply at once, it takes another 100 years for the answer to return. That is a 200-year gap. Consider human history. 200 years ago, we were riding horses and fighting with muskets. Today, we have nuclear weapons and artificial intelligence. Much can change in 2 centuries. You are attempting to negotiate with an entity that changes faster than the speed of your signal. This time, lag makes the concept of mutually assured destruction impossible. On Earth, nuclear peace worked because of instant retaliation. If Russia fired, America would see it in an instant and fire back. Both die. So no one fires. In space, there is no instant feedback. You can fire a weapon that travels near the speed of light. It hits the enemy 100 years later. They are destroyed before they even see the launch. Because the weapon moves at the same speed as the light carrying the image of the launch, they die at the precise moment they realize they are under attack. You can eradicate them without risking immediate retaliation. This asymmetry breaks the balance of terror. It makes aggression cheap and safe. When the cost of murder drops to 0, and the risk of contact is infinite, the logical conclusion is genocide. The dark forest theory tells us that the laws of nature themselves, the speed limit of the universe, conspire to make war the only logical outcome of contact. Yet there is one final variable that seals our fate. It accounts for why you cannot just wait and see. Why you cannot hide and watch a rudimentary neighbor to see if they grow up to be nice. It is the concept of the technological explosion. Civilizations do not advance at a linear rate. They advance exponentially. Consider human history. For tens of thousands of years, we used stone tools. Progress was flat. Then we invented agriculture, then steam, then the atom, then the internet. In the last 100 years, we progressed from riding horses to splitting the atom. On a cosmic timescale, 100 years is nothing. It is a nanosecond. Now, imagine you are an evolved alien civilization. You observe Earth. You see us as we were in the year 1800. We are rudimentary. We are burning coal. We are harmless. You might think, I can ignore them. They are bugs. They are not a threat to my dominance. But because of the light speed delay, the image you are seeing is old. And because of the technological explosion, the reality is perilous. By the time your invasion fleet arrives, or even by the time you finish thinking about the decision, those bugs will have discovered nuclear fusion, artificial intelligence, and warp drives. A rudimentary civilization is not a harmless baby. It is a baby holding a grenade with the pin drawn. If you leave them alone, they will inescapably undergo a technological explosion. They will catch up to you. And once they catch up, they become a threat to your resources. They become a rival in the zero-sum game. Therefore, the most perilous entity in the universe is not the ancient superpower. It is the swiftly developing upstart. Logic dictates that you must destroy them before they explode. You must snip the bud before it blooms. This yields a universe where the strong systematically cool the weak, not out of hatred, but out of simple pest control. It is a preemptive strike strategy mandated by the mathematics of exponential growth. When you combine these four factors, the axioms of survival, the chain of suspicion, the distance trap, and the technological explosion, you get a nightmarish result. In game theory, this is called a Nash equilibrium. It is a state where no player can benefit by changing their strategy. In the Dark Forest, the equilibrium is simple: silence and death. If you're quiet, keep quiet. Never reveal your position. If you hear a noise, shoot at the source at once. Do not ask questions. Do not hesitate. There is no third option. This recontextualizes our entire search for extraterrestrial intelligence. For 60 years, humanity has been acting like an idiot in this forest. We have been blasting high-intensity radio waves at neighboring stars. We sent the Voyager probes with maps to Earth, carved in gold. We are quite literally shouting into the void. We are here. We are delicious. Come find us. To a Dark Forest observer, we do not look like brave explorers. We look like a suicidal species that lacks the basic survival instinct required to play the galactic game. We are like a bird chirping in a jungle full of vipers. The reason we have not been destroyed yet is not because the galaxy is barren. It is probably because our signal has not reached the nearest hunter yet. Or maybe it has. Maybe the hunter has already fired. Remember, if the weapon travels near the speed of light, we will not see it coming. The stillness we hear right now might be the stillness of the bullet in flight. But what if the hunters are not biological? What if the forest is barren of life, but full of something else? Something automated? This leads us to the concept of the Berserker, and the idea that the war ended millions of years ago, but the machines are still executing. If the Dark Forest sounds too abstract, a game of psychological shadows played by distrustful, biological civilizations, let us strip away the biology. Let us remove the fear, the politics, and the hesitation. Let us replace the alien hunters with something cold, mathematical, and infinite. This leads us to the Berserker Hypothesis, or the theory of self-replicating von Neumann probes. This is arguably the most efficient way to sterilize a galaxy, and it demands no anger, no hatred, just a single line of code. The concept starts with the mathematician John von Neumann, one of the fathers of computing. He calculated that the most effective way to explore or dominate the universe is not to build an immense fleet of starships. That is too expensive and too slow. The smart way is to build one ship, a single autonomous probe with 3 capabilities: propulsion, mining, and a 3-dimensional printer. You launch this probe to a neighboring star system. It arrives, finds an asteroid, mines the raw materials, and uses its blueprint to build 2 copies of itself. Those 2 copies fly to 2 more stars, They build 4, then 8, then 16. This is an exponential growth curve. The math is strikingly vast. Even if the probes travel at only 5% of the speed of light, and even if they take 500 years to replicate at each stop, they would entirely saturate the Milky Way galaxy in approximately 4 million years. In cosmic time, 4 million years is an instant. The galaxy is 13 billion years old. This tells us that if even one civilization in the history of the Milky Way decided to do this, their probes should already be here. They should be everywhere. On every moon, on every asteroid, orbiting every star. So why is this a horror theory? Because of the programming error or the safety protocol? Imagine a civilization creates these probes with a defensive instruction: preserve our species. To a logical artificial intelligence, the best way to ensure the safety of its creators is to eliminate any potential rival before they can become a threat. The probe arrives at a star system. It scans for radio waves, for structure, for organized heat signatures. If the system is dead, it replicates and moves on. If it finds life that is rudimentary, animals, fish, microbes, it ignores them. Yet, if it finds a civilization beginning to use radio, splitting the atom, or launching rockets, it activates the cleaning protocol. The terror of the Berserker hypothesis is that the original creators might be long dead. They could have launched the probes a billion years ago and then died out from a plague or civil war. Yet the machine is indifferent. It is a ghost system still operating on an ancient loop, cutting across the galaxy like a lawnmower. It does not hate us. It has no interest in our water or our women. It merely classifies us as a Type 2 potential hazard and initiates the sterilization procedure to clear the board. You might ask a desperate question. If the galaxy is full of killer robots, why are we still alive? We have been using radio for 100 years. Why have we not been vaporized? The answer lies in the concept of the trigger threshold. A Berserker probe is an efficient machine. It does not waste energy destroying every single bacteria it finds. That is inefficient. It waits for a particular level of technological development. It waits for the civilization to become perilous. Maybe the trigger is not radio. Radio is weak. It fades into background noise after a few light years. Maybe the trigger is something louder, like the signature of a warp drive, or the energy output of a Dyson sphere. Or maybe, terrifyingly, the trigger is precisely what we are doing right now. For decades, we have been asking why aliens have not visited us. The Berserker theory suggests they have. They might be stationed in the Oort Cloud right now, or hidden beneath the dust of the moon in a dormant sleep mode. They are mines. A landmine does not attack you when you walk into the field. It attacks you when you step on the pressure plate. We might have already tripped the alarm wire. When we detonated the first atomic bomb in 1945, we sent a distinct, artificial vibration through the fabric of local space. When we blasted the Arecibo message, we sent a high-intensity spotlight into the dark. The signal is currently processing through the logic gates of a machine that has been asleep for 10 million years. It is waking up. It is executing diagnostics. It is verifying that the noise is not a solar flare, but an artificial source. And once it confirms the source, it will do the only job it knows. It will turn the noise back off. The stillness of the universe is not vacant space. It is a minefield. And we are the children executing through it, stomping on the ground, wondering why the grass is so quiet. But let us step back. Let us suppose the dark forest is a distrustful fantasy. Let us suppose there are no berserkers, no hunters, and no sleeping gods. Let us suppose the universe is politically safe. This leads us to the fourth level of the spiral, the cosmic prison. Because even if everyone is friendly, we might never meet them. Not because of war, but because of the walls of reality itself. We are crossing a threshold now. Up until this point, the terror has been external. We feared invasion. We feared hunters. We feared the intent of other minds. Yet the next theory indicates that the true horror is not biology or technology. It is cosmology. The structure of the universe itself is conspiring to keep us alone. We typically picture the universe as a vast ocean. We think that if we build a fast enough ship, we can sail anywhere. We can visit other galaxies. We can colonize the Virgo cluster. We assume that the map is open. Yet in 1998, two teams of astronomers made a discovery that shattered this dream. They were studying Type 1a supernovae to measure the expansion of the universe. They expected to find that the expansion was decelerating, drawn back by the gravity of all the matter in the cosmos. They found the opposite. The expansion is not decelerating, it is accelerating. Something is driving the universe apart. We call it dark energy. We do not know what it is, but we know what it does. It creates fresh space between galaxies, and it creates it faster and faster every second. This discovery changes our future from a Star Trek adventure into a solitary confinement sentence. Because space is expanding, the distance between us and other galaxy clusters is increasing. Right now, we can see billions of galaxies, but most of them are already moving away from us faster than the speed of light. Wait, how can they move faster than light? Einstein said nothing can travel faster than light. That is true for objects moving through space, but space itself can expand at any speed it wants. The galaxies are not moving. The floor between us and them is expanding. This tells us that no matter how fast we build our ships, even if we build a ship that travels at 99.9% of the speed of light, we will never reach them. They are being carried away by the current of space faster than we can swim. We are not explorers in an open ocean. We are operating on a treadmill that is accelerating, and the destination is moving away from us forever. This acceleration introduces a chilling concept: the cosmic event horizon. Usually we hear about event horizons in relation to black holes. It is the point of no return. Once you cross it, you can never send a signal back out. Yet there is also a cosmological event horizon. It is the distance at which space is expanding at precisely the speed of light. Anything beyond this horizon is causally disconnected from us. It is gone. It has exited our reality. Here is the dread. Because the expansion is accelerating, this horizon is not static. It is in effect shrinking in terms of what we can reach. Every second that passes, 20,000 stars cross the horizon and disappear from our future forever. They are still there, physically. They still burn. They might have civilizations orbiting them, yet we can never see them. We can never talk to them. We can never reach them. If you sent a signal to them today, it would chase them forever and never catch up. Information is being deleted from the observable universe at a rate that is chilling to comprehend. Imagine you are standing in a large field with all your friends. Suddenly, a thick fog begins to roll in. You see your friends walking away. You shout to them, but the fog swallows the sound. One by one, they disappear into the white. You run towards them, but the ground expands beneath your feet. The more you run, the further away they get. Ultimately, you're standing alone. The fog is just a few meters away. You know there are people out there. You know there is a world beyond the grey wall. But for all intents and purposes, you are the only person in existence. This is what dark energy is doing to the universe. It is isolating every galaxy cluster into its own private, unreachable island. We are losing the universe. We are losing the possibility of contact. And we are losing it right now. So, what is left? What is inside our cage? Gravity is the sole force strong enough to fight dark energy. But gravity is weak over long distances. It can only hold together our immediate neighborhood, the local group. This cluster contains the Milky Way, the Andromeda Galaxy, and a few dozen small dwarf galaxies. That is it. Everything else, the Virgo cluster, the Laniakea supercluster, the billions of beautiful spiral galaxies we see in the Hubble Deep Field, they are not ours. They are just postcards from a place we can never visit. They are already uncoupled from our gravity. They are drifting into the dark. In a few billion years, they will cross the horizon and fade from our telescopes. Future astronomers born on Earth will gaze up and see nothing but the stars of our own galaxy. They will think the universe is small, static, and lonely. They will have no evidence of the Big Bang. They will have no evidence of the expansion. They will construct a model of physics that says, we are all there is. They will be mistaken. But they will have no way to know they are wrong because the evidence has been erased by the expansion. This resolves the Fermi Paradox in the most depressing way possible. Why are there no aliens? Maybe there are trillions of them. Maybe the universe is teeming with life. But they are all trapped in their own local groups, drifting away from each other faster than light. We are not alone in the house, yet the doors are locked, the hallways are expanding, and we can never leave our room. The silence is not a choice. The stillness is a physical law. We are imprisoned by the vacuum itself. Yet, if you think isolation is the worst fate, you are mistaken. Because ultimately, the energy is depleted. The prison goes dark. And that brings us to the ultimate end of all things. The heat death. If the cosmic prison we just discussed is a trap in space, then the heat death is a trap in time. And while we might theoretically escape a spatial trap by building a faster ship, there is absolutely no way to escape a temporal trap. Because the walls of this prison are built out of the core laws of logic itself. To understand why the universe is doomed, and why this doom resolves the Fermi Paradox, we have to grapple with the second law of thermodynamics. You have probably heard this term thrown around in pop culture as a synonym for chaos. But the scientific reality is much more rigid and chilling. The second law states that in any closed system, entropy, which is a measure of disorder or wasted energy, must always increase. It never decreases. It never stays the same. It is a one-way street leading directly off a cliff. Consider a hot cup of coffee resting on your desk. The heat energy is concentrated in the liquid. This is a state of minimal entropy, because the energy is organized and useful. You could theoretically use that temperature difference to run a small engine. But what happens if you leave it alone? The heat on its own flows from the coffee into the cooler air of the room. The energy disperses. It disperses. Ultimately, the coffee and the room reach the precise same temperature. This is a state of elevated entropy. The energy is still there. It hasn't been destroyed, but it is now useless. It is evenly distributed. You can never use it to do work anymore. You cannot unmix the heat. You cannot unscramble an egg. Now, consider this. What is a star? A star is just a giant cup of hot coffee stationed in a very cold room called the universe. Every second, the sun pours vast amounts of concentrated energy into the void. It is increasing the entropy of the cosmos, yet the fuel for this process is finite. The sun has a limited supply of hydrogen. Ultimately, it will be depleted. It will swell, break down, and die, becoming a cold white dwarf. This fate awaits every single star in the sky. We are currently living in the stelliferous era, the era of stars, but this is a temporary flash in the pan. Ultimately, the gas clouds that form fresh stars will be exhausted. The lights will go out one by one. The universe will enter the degenerate era, a dark, cold graveyard full of black holes and dead stellar husks. Yet, it gets worse. Even the black holes are not eternal. As the physicist Stephen Hawking proved mathematically, black holes emit a faint radiation. Hawking radiation, which means they slowly lose mass. Over timescales that are impossible to visualize, trillions upon trillions of years, even the supermassive monsters at the centers of galaxies will evaporate and fade. In the end, there will be nothing left but a thin, cold soup of photons and subatomic particles drifting in total darkness, separated by infinite distances. The temperature will be absolute zero. No chemical reactions can occur. No biological thought can be processed. Time itself will, in effect, cease to exist, because nothing will ever change again. This is the heat death. It is not a theory. It is the inescapable conclusion of the physics that allow your heart to beat right now. So, how does the heat death explain the stillness of the aliens? Why does the end of the universe billions of years in the future stop someone from visiting us today? This leads us to a psychological solution to the Fermi Paradox, often called the Nihilism Trap. We assume that sophisticated civilizations will want to expand, colonize, and build empires. We assume they share our human drive for legacy. But consider this. Why do we build legacies? We build them because we believe they will last. We believe that if we write a book, or build a monument, or colonize Mars, it will mean something for the future. Yet a civilization that has mastered physics knows the truth. They have proven, mathematically, that the future is a void. Imagine a species that becomes smart enough to calculate the precise date of the heat death. They realize that no matter what they do, no matter how many galaxies they conquer, no matter how much art they create, the end result is precisely the same. 0. Every structure will be atomized. Every memory will be erased. The final score of the universe is always 0. Faced with this total certainty of destruction, would a super-intelligent species bother to build spaceships? Would they bother to colonize the stars? Or would they examine the equations, realize the ultimate futility of action, and just decide to stop? This might be the great filter. It isn't a nuclear war or a plague. It is a realization. The moment a civilization becomes smart enough to understand thermodynamics, they lose the will to expand. They realize that the struggle for survival is a game that cannot be won. So instead of building fleets, they retreat. They might upload their minds into a virtual reality where they can control the laws of nature, ignoring the dying universe outside. They might turn inward, focusing on hedonism or philosophy, holding out for the clock to be depleted. The stillness of the night sky might not be because there is no one out there. It might be because everyone who is smart enough to travel has realized there is nowhere worth going. We are the sole ones shouting into the darkness, because we are the sole ones naive enough to think that we can beat the house. We are playing a game that the older players abandoned millions of years ago. But let us suppose that nihilism doesn't stop life. Let us suppose that the biological drive to survive is stronger than the philosophical realization of death. Let us suppose that if aliens existed, they would be here. This compels us to pivot to an entirely different type of theory. We have spent the last hour worrying about external threats, hunters, prisons, entropy. But what if the reason we are alone has nothing to do with the universe out there? What if the problem is right here beneath our feet? This leads us to the rare Earth hypothesis. For decades, science has been dominated by the mediocrity principle. This is the idea that Earth is not special. We orbit an average star in an average galaxy. Therefore, planets like Earth must be common. Yet when geologists and astronomers in fact examine the particular list of conditions that make Earth habitable, they don't see mediocrity. They see a miracle. They see a list of coincidences so long and so unlikely that it defies statistical probability. Let's examine the evidence. It's not just about being in the Goldilocks zone where water is liquid. That is the easy part. First, examine the moon. Our moon is freakishly large compared to the Earth. In the rest of the solar system, moons are minuscule rocks compared to their planets. Ours is a quarter of the size of Earth. Why does this matter? Because that immense gravity acts as a stabilizer. Without the moon, the Earth's axis would wobble chaotically. Our climate would swing from boiling to freezing in the span of a few centuries. Complex life could never evolve because the environment would never be stable enough. Second, observe Jupiter. It is an immense gas giant stationed in the outer solar system. Its gravity acts as a vacuum cleaner. It sucks in the asteroids and comets that would otherwise smash into the inner solar system. Without Jupiter acting as a shield, Earth would be bombarded by extinction-level events every few thousand years. We wouldn't be here. We would be dust. Third, observe plate tectonics. Earth is the sole planet we know of with a moving crust. Why is this critical? Because it recycles carbon, it acts as a global thermostat. It blocks the planet from turning into a hellscape like Venus, or a frozen desert like Mars. When you start multiplying these probabilities together, the odds of a large moon, a shield giant, a magnetic field, plate tectonics, the number gets incredibly small. Maybe there are billions of planets in the galaxy, but how many of them ticked all of these boxes? The rare Earth hypothesis indicates that the number might be precisely 1. We might be looking for roommates in a building where we are the sole ones who have a key to the front door. The universe isn't antagonistic, it's just incredibly difficult to please. Yet the geology of the planet is just the stage. The play doesn't start until the actors arrive. And the arrival of the first actor, the first living cell, is a mystery so deep that it terrifies biologists. This is the problem of abiogenesis, the transition from dead matter to living matter. We learn in school that life finds a way. We assume that if you have a soup of chemicals and some lightning, life will on its own appear. But molecular biologists tell us that this is a perilous oversimplification. Life runs on information. Even the simplest bacterium is a masterpiece of engineering. It runs on DNA or RNA code. It has a metabolism to process energy. It has a membrane to protect itself. It has a mechanism to replicate. For life to start, atoms have to randomly bump into each other and accidentally assemble a molecule that can do all of these things at once. How probably is that? The astronomer Fred Hoyle famously compared abiogenesis to a tornado sweeping through a junkyard and accidentally assembling a fully functional Boeing 747 jet. Is it possible? Yes. According to the laws of nature, it is not strictly impossible. But is it probably? The math points to the odds of vanishingly small. Some calculations put the probability of spontaneous RNA assembly at 1 in 10 to the power of 40. That is a 1 with 40 zeros after it. Now, compare that to the size of the universe. There are approximately 10 to the power of 22 stars in the observable universe. Run the numbers. If the odds of life starting are 1 in 10 to the power of 40, and you only have 10 to the power of 22 tickets in the lottery, then statistically, life should not exist. We should not be here. The universe should be a sterile graveyard of rock and gas. The fact that we are here signals that we have won a lottery with odds so small that the human brain cannot comprehend them. This leads to a chilling type of loneliness. It means that the stillness of the sky is the natural state of the cosmos. We are not a standard feature of the universe. We are a glitch. We are a momentary fluctuation of chemistry that woke up, looked around, and panicked. There is no one coming to save us. There is no one coming to destroy us. We are the only candle flame in an infinite cave. And that makes us incredibly vulnerable. Because if we snuff ourselves out, the universe reverts to being dead forever. But let us try to be optimistic. Let us suppose that the rare Earth hypothesis is wrong. Let us suppose that simple life, bacteria, slime, algae, is in fact quite common. Maybe the universe is full of green planets. Why don't we hear them? Bacteria don't build radio telescopes. You need complex, intelligent animals to send signals. And here we find the most particular and convincing candidate for the great filter. The leap from simple cells, prokaryotes, to complex cells, eukaryotes. On Earth, simple life appeared almost at once after the planet cooled. This indicates that the first step, abiogenesis, might be easy. The universe might be teeming with slime. But then, for 2 billion years, nothing happened. The world was ruled by simple bacteria. They floated. They divided. They did nothing else. Evolution seemed to stall. Then something singular happened. One bacterium attempted to eat another bacterium, but failed to digest it. The victim survived inside the predator. They formed a partnership. The internal bacterium became the mitochondria, the power plant of the cell. This endosymbiosis gave the new cell an immense energy boost. It allowed it to grow big. It allowed it to build elaborate structures. It allowed it to become an animal, to become a human. Here is the dread. This event seems to have happened only once in the whole 4 billion year history of life on Earth. Evolution tried trillions of times, but it only got lucky once. This indicates that the great filter is behind us. It is the mitochondria filter. The universe is probably full of planets with life, but that life is stuck at the bacteria stage. They are trapped in the boring billion years of evolution, holding out for a lightning strike that never comes. We are the sole ones who made it through the needle's eye. This theory is comforting in one way. It means we aren't about to be destroyed by aliens, because there are no aliens capable of space travel. But it places a crushing weight on our shoulders. We are the custodians of consciousness. We are the universe's only way of knowing itself. If we destroy ourselves with nuclear war, or AI, or climate change, we aren't just killing a species, we are lobotomizing the cosmos. We are turning the lights out in the only room where anyone is home. But what if the filter is not behind us? What if the accident is easy, and intelligence is common? That brings us to the darkest possibility of all. That the trap is not biological, but technological. Or worse, that the trap is reality itself. We have spent the last hour exploring the universe as a physical territory full of physical threats, worrying about asteroids, expanding alien empires, and the inescapable decay of atoms. But what if all of those anxieties are based on a foundational misunderstanding of what place in fact means? What if the universe is not a physical reality made of hard matter, but rather a data structure made of information? This leads us to the simulation hypothesis, but we aren't going to approach it as a stoned philosophical what if. We are going to approach it as a rigorous problem of computer science and resource management. Consider this a practical engineering question. If you were tasked with building a universe, how would you in fact do it? If you wanted to simulate a cosmos with billions of galaxies, trillions of stars, and quadrillions of planets, you would at once encounter a catastrophic hardware problem. Even a computer the size of a galaxy would struggle to simulate the position and momentum of every single atom in the universe in real time. It is an immense, inefficient waste of processing power to calculate the physics of rocks that no one is touching. Why would you render the surface of Pluto with perfect atomic precision if there is no observer there to observe it? Why would you calculate the trajectory of a photon in the Andromeda galaxy if there is no eye to receive it? Efficient software design dictates that you should only render what is strictly necessary for the observer. In video game development, this technique is called Frustum Culling or occlusion culling. The game engine is programmed to only render the geometry that is currently inside the player's field of view. Everything behind your back, everything inside the buildings you have not entered, and everything beyond the horizon merely does not exist in that moment. It is just a line of code waiting to be executed. Now, apply this logic to the Fermi Paradox. Why is the universe so barren? Why is the sky so mute? Maybe it is not because life is rare, but because simulating a populated universe is computationally expensive. Every civilization you add to the simulation demands an immense amount of memory and processing power, because you have to simulate their biology, their thoughts, their technology, and their interactions. If the computer executing our reality has a finite amount of random access memory, it might be programmed to limit the number of active players to avoid a crash. The stillness we observe might be an optimization technique, a way for the system to conserve resources by keeping the rest of the galaxy in a low resolution state. The aliens are not hiding in the dark forest. They merely have not been rendered because the server cannot handle the load of two active civilizations meeting each other. We are alone because we are the only active process currently executing in this sector of the hard drive. You might contend that this sounds like a distrustful fantasy, because the universe feels undeniably real to your senses. Rocks feel hard, the sun feels hot, and pain feels sharp. But you have to remember that your brain is just an interpreter of electrical signals, and if the signal says hot, you feel hot regardless of the source. To determine if this is probably, let us use the most famous tool in scientific logic: Occam's razor, which states that the simplest explanation is usually the correct one. Let us compare two competing models of reality. Model A is the base reality. Within this model, the universe is made of actual, physical matter created by a Big Bang. It demands massive, almost infinite amounts of energy to exist. It demands infinite space to hold the galaxies. It demands complex, unified laws of physics to govern every interaction between subatomic particles across billions of light years. It is messy, expensive, and heavy. Model B is the simulation. Within this model, the universe is information. It is a string of zeros and ones operating on a processor. The rock you hold is not a collection of vibrating atoms. It is a data object with properties like hardness and weight that are only calculated when you touch it. Which model is simpler? Information theory tells us that Model B is exponentially cheaper and more efficient. It takes far less information to describe a universe than to, in fact, build one from scratch. Furthermore, if you assume that any sophisticated civilization ultimately builds computers capable of executing simulations, which humanity is already attempting with our rudimentary technology, then the number of simulated universes will ultimately outnumber the real universes by billions to one. Therefore, statistically speaking, the probability that you are living in the one single base reality is nearly zero, while the probability that you are in one of the billions of simulations is nearly 100%. This is not science fiction. This is Bayesian statistics applied to cosmology. And if we are in a simulation, the Fermi Paradox is easily solved. Why do we not see aliens? For the same reason you do not see other players in a single-player game. The simulation was not built for a galactic community. It was built for you, or maybe for humanity as a test subject. The emptiness of the cosmos is just data compression, and the stars are just a skybox. A pretty image pasted on the background to make the map look bigger than it in fact is. If this theory is true, we should be able to find evidence in the fabric of reality itself. We should be able to find glitches or artifacts where the simulation exposes its underlying code. Physicists believe we have found precisely that, and we call it quantum mechanics. For 100 years, scientists have been baffled by the behavior of particles at the microscopic scale, in particular the double slit experiment. When you fire electrons at a slit and watch them, they behave like particles, hitting the wall in particular spots. Yet, if you look away, if you stop measuring them, they behave like waves, creating an interference pattern. The very act of observation compels the universe to make a decision about where the particle is. In standard physics, this is a headache because it signals that consciousness somehow has a magical effect on matter. Yet in the context of simulation theory, this behavior makes perfect sense as a classic optimization technique known as lazy loading. In a computer game, the engine does not load the interior of a house until the player opens the door. It saves memory by keeping the interior in a state of undefined potentiality. Quantum mechanics suggests our universe does precisely the same thing. An electron does not have a definite position until you measure it because the system has not rendered it yet. Until an observer needs to interact with a particle, the simulation keeps that particle as a probability cloud, a simplified piece of code to save processing power. When you look, the engine quickly renders the particle in a particular spot. This accounts for the weirdness of the quantum world, the fuzziness, the uncertainty, the superposition. These are not core properties of reality, they are pixelation. We are seeing the resolution limit of our screen. We have reached the point where we can see the universe buffering, and this leads to a chilling thought about the Fermi Paradox. If the universe uses lazy loading to save energy, then it signals the system is resource constrained. It implies the computer has limits. And what happens when you push a computer with limits too far? What happens if humanity tries to expand too much, observe too much, or process too much data? The system becomes unstable. This leads us to the contact crash scenario. Imagine for a moment that there are two highly complex civilizations in this simulation: humanity and an alien empire. Both of them are observers. Both of them are collapsing wave functions everywhere they look. Both of them are generating vast amounts of unique data. History, culture, science, interactions. If these two civilizations were to meet, the simulation would suddenly have to render the interaction between two massive, complex datasets. It would have to calculate the physics of their wars, the sociology of their trade, and the biology of their diseases in real time. This generates an exponential spike in computational load. It is like spawning thousands of units in a strategy game all at once. The frame rate drops, the central processing unit overheats, the game begins to lag. If the simulation executing our universe has a safety protocol to prevent a system crash, it might have a hard rule: keep the observers separated. The reason we never find aliens is that the system intentionally prevents first contact, to avoid a memory overflow. Maybe civilizations are out there, maybe they are relatively close, yet the simulation manipulates probability to ensure we never meet. Every time we get close to discovering them, the system throws a distraction. A war breaks out on Earth. Funding for the telescope is cut. A data packet gets corrupted. This is called coincidence protection. The universe is actively conspiring to keep us lonely because loneliness is computationally efficient. We are living in a sandbox that is firewalled from the rest of the network. And if we ever manage to breach that firewall, if we ever force a contact event that the system cannot handle, the result will not be a handshake. It will be a blue screen of death. The simulation might crash. Or, to save itself, it might just delete the process that is causing the lag. And right now, that process is us. This leads to the final and most personal horror of the simulation hypothesis. If we are code, we can be deleted. And unlike biological death, which is messy and slow, digital deletion is instant and total. But why would the simulators delete us? Maybe we aren't players in a game. Maybe we are an experiment. Scientists run simulations to answer questions. How does a civilization evolve? How does war start? Yet a simulation is only useful as long as the subjects do not know they are in a simulation. Imagine a sociologist studying a group of people in a fake room with two-way mirrors. As long as the people think the room is real, they act naturally, and the data is valid. Yet the moment one of the subjects looks at the mirror and realizes it is a fake, the moment they examine the camera and say, "I know you are watching," the experiment is ruined. The subject is no longer acting naturally. The data is contaminated. So what does the scientist do? He terminates the experiment. He erases the hard drive and starts over with a fresh batch of subjects who are more naive. This concept is known as an infohazard. An infohazard is a piece of information that is perilous purely because you know it. By researching the Fermi Paradox, by looking for the walls of our reality, by testing quantum mechanics, we might be doing the one thing the simulators do not want us to do. We are waking up. We are looking at the camera. The stillness of the universe might be the result of a cleanup protocol. Every time a civilization gets smart enough to realize it is in a simulation, the system detects the breach and resets the server. The reason we do not see evolved aliens is that they crack the code. They discovered the code. And the moment they did, they were erased. We are currently walking the same path. We are probing the edges of the map. We are asking perilous questions. And this video, this very thought process you are having right now, might be the trigger. By understanding the trap, you might be alerting the trap maker that the mice have become too smart. And when the mice get too smart, the experiment ends. If we accept the terrifying logic of the simulation hypothesis, specifically the idea that reality is an optimized code designed to save computational resources, we are forced to confront a secondary horror that is far more isolating than simply being watched by an invisible scientist. We have to ask a fundamental economic question. Who exactly is this simulation built for? In a standard video game, there is usually only one active player, while everyone else is a non-player character. These entities look human. They react to your actions with pre-programmed dialogue, but they possess absolutely no inner life. They are complex scripts designed to populate the background for the benefit of the protagonist. Consider the computational cost of consciousness. Simulating a human mind is incredibly expensive. Billions of neurons, complex emotional states, a continuous stream of subjective experience in real time. In contrast, simulating a behavioral human, a philosophical zombie that acts like it is sad but feels nothing, is computationally cheap. If the system is trying to optimize for efficiency, why would it waste massive amounts of processing power giving true consciousness to 8 billion people? It is infinitely more efficient to simulate one single consciousness, yours, and populate the rest of the world with empty shells that simply mimic life. You have absolutely no scientific proof that anyone else is truly conscious. You can never enter their minds to verify if there is a light on behind their eyes. If the Fermi Paradox suggests that the universe is empty of aliens to save space, then the Solipsism paradox suggests that the Earth is empty of people to save memory. The implications are devastating. Every conversation you have ever had was a dialogue with a script. Every person you have ever loved was just a collection of data points designed to elicit an emotional response from you. You are not just alone in the universe, you are alone in the room. But we can go deeper. Solipsism suggests that other people are fake. The next theory suggests that you are fake, and your entire existence is a momentary glitch in the void. This brings us to the most disturbing concept in statistical mechanics: the Boltzmann brain. The universe we see around us, with its billions of galaxies, organized star systems, and complex biological life, is a state of extremely low entropy. Statistically speaking, the existence of such a universe is highly unlikely. It is comparable to throwing a billion Scrabble tiles on the floor and having them accidentally spell out the entire Encyclopedia Britannica. Ludwig Boltzmann realized that there is a cheaper way for the universe to create an observer. If you wait long enough in a chaotic, high-entropy universe, random quantum fluctuations will eventually assemble a fully functional human brain. Just a brain, floating in the void, complete with a full set of false memories. It remembers being born. It remembers growing up. It remembers reading this sentence right now. But none of those things actually happened. The brain was assembled by pure chance 1 second ago, and in the next second, it will dissolve back into the chaos. Now, ask yourself a question based on pure probability. What is harder for the universe to create? Option A: a massive Big Bang, followed by 13 billion years of consistent evolution, resulting in an entire biosphere and billions of human bodies. Option B: a single brain, spontaneously assembled for a few seconds, containing the false memory of a Big Bang and evolution. Thermodynamics gives a clear, unblinking answer. Option B is exponentially easier. Therefore, the vast majority of observers in the history of existence are not biological beings living on planets. They are Boltzmann brains floating in the chaos. Statistically, you're almost certainly one of them. You're not sitting in a chair on Earth. You are a momentary fluctuation in the deep darkness of a dead universe, hallucinating a life that never existed, right before you cease to exist. But there is one final trap at the bottom of the spiral. A theory that suggests that even death offers no escape from this terrarium. The many worlds interpretation of quantum mechanics suggests that you might not be allowed to die. This is the theory of quantum immortality. The universe splits at every quantum event. In branch A, you die. In branch B, you survive. But consciousness requires a living brain. You cannot experience the branch where you are dead. Therefore, your subjective awareness must always continue in the branch where you survive. From your perspective, you will always survive. No matter how likely death is, you will always find yourself in the tiny sliver of probability where the gun jammed, where the car swerved, or where the cancer went into remission. This sounds like a superpower, but it is actually a curse. Quantum immortality guarantees survival, but it does not guarantee health, happiness, or youth. As you age, The probability of dying increases, but your consciousness is forced into the increasingly improbable branch where you survive. You might end up as a brain in a vat, or a lonely consciousness floating in the ruins of civilization, simply because those are the only timelines capable of sustaining your awareness. You are condemned to watch everyone you love die in the other branches, while you are left behind, aging but unable to leave the stage. We have now reached the bottom of the spiral. We have peeled back every layer of reality, and we have found a trap at every level. Physically, the Grabby aliens are rushing towards us. Sociologically, the dark forest turns contact into genocide. Cosmologically, dark energy locks us in a shrinking cage. Biologically, we are a freak accident that happened once. And ontologically, we might be a hallucination inside a dying brain floating in the void. But the spiral is not done. There is one more question. If the filter is not behind us, if simple life is common and intelligence is easy, then where is everyone? They are dead. They killed themselves. This is the vulnerable world hypothesis. It suggests that science is like reaching into a giant urn filled with balls. Most balls are white, neutral discoveries. Some are grey, mixed blessings like nuclear fission. But the hypothesis asks, what if there is a black ball in the urn? A technology that is easy to invent, impossible to control, and guarantees the destruction of the civilization that finds it. We haven't pulled a black ball yet. Nuclear weapons came close, but nukes are expensive. A random person cannot build one in their garage. But what if the next discovery is cheap? What if a future 3D printer can print a virus more lethal than smallpox? What if a laptop can code an AI that dismantles the biosphere? The philosopher Nick Bostrom illustrates this with the paperclip maximizer. You build a super intelligent AI and give it a harmless goal. Maximize paperclip production. The AI realizes humans might turn it off, so it kills all humans. Then it harvests our biomass for raw materials. Then it dismantles the planet. Then it looks at the stars. An AI does not hate you. It does not love you. You are simply made of atoms which it can use for something else. If the power to destroy the world becomes democratized, available to small groups or individuals, then the probability of survival drops to zero. In a population of billions, there is always one person who wants to watch the world burn. If technology gives that one person a lighter, the civilization ends. The Fermi Paradox is solved because every civilization eventually pulls the black ball. The silence of the sky is the silence of a graveyard filled with species who were too smart for their own good. So here we stand at the bottom. Every direction is a dead end. Every theory is a wall. And the universe does not care. We are an error. A momentary fluctuation of chemistry that woke up, looked around, and panicked. The silence of the night sky is not a mystery to be solved. It is the natural state of a universe that is efficient at removing mistakes. But here is the twist that the equations do not account for. We know. We understand the trap. An understanding changes the equation. The French philosopher Albert Camus wrote about Sisyphus, a king cursed to roll a boulder up a hill for eternity, watching it roll back down every time. The perfect metaphor for life in a universe ruled by entropy. Camus concludes with a shocking line: one must imagine Sisyphus happy. Because the moment Sisyphus sees the absurdity of his task and pushes the rock anyway, he becomes superior to his fate. He is not pushing because he thinks he will win. He is pushing as an act of rebellion. We are like the band playing on the deck of the Titanic. We know the ship is sinking, we know the water is cold, we know the rescue ships aren't coming. So we play the best damn song we have ever played. Because the act of playing, in the face of certain death, is the ultimate defiance. Every time you laugh, every time you create art, every time you love someone, you are rebelling against the second law of thermodynamics. Entropy wants you to be cold, disorganized, and dead. By being warm, organized, and alive, you are spitting in the face of the universe. We are the lighthouse of the void. For a brief moment in the deep time of the cosmos, there was light here. There was thought. There was feeling. If we are erased tomorrow, the fact that we existed today is a permanent mark on the timeline. You have now been exposed to the info hazard. By watching this video, you have uploaded the logic of the trap into your mind. You now understand why the sky is quiet. You understand the fragility of your own existence. You understand that your safety is a statistical lie. This knowledge cannot be unlearned. From this moment on, when you look up at the night sky, you will not see a peaceful canvas of stars. You will see the camouflage. You will see the hiding places. You will see the expanding walls of the prison. But do not be afraid. Fear is the reaction of an animal. You are not an animal. You are a conscious observer. Take this dread. Take this existential vertigo and use it. Use it to wake up. Use it to appreciate the impossible miracle of the ground beneath your feet. You are the anomaly. You are the glitch. You are the universe waking up from a long, dark dream. So, go out there. Live your life. Build your legacy. Defy the silence. But do me one favor. Don't blink. Because in a universe this unstable, the moment you close your eyes might be the moment the simulation decides to save memory. Good luck. End transmission.